Section 7.2, the inverse trig functions continued. Secant, cosecant, and cotangent also have inverse functions on restricted domains. Let's look at secant first. Y equals secant, inverse secant of x means that x is the secant of y when x is greater than or equal to 1 or less than or equal to -1 and y is in between 0 and pi, not equaling pi over 2. So recall that the domain, what's going on? Hold on, my pen's not working, hold on. Okay, recall that the domain of the inverse function will be the same as the range of the function and vice versa. So right here I have the function of secant x, right? And notice that the domain of this function on which there's an inverse is from 0 to pi over 2 and pi over 2 to pi, including 0 and pi. So that's the same as the y, or as the range here. And the range of secant on the graph is greater than or equal to 1 and less than or equal to 1, which is the domain of this function. Okay? So we can say that f of x equals, oops, I didn't mean to write sex. F of x equals secant x, right, has an inverse on 0 to pi over 2 union pi over 2 to pi. And something is going on with my pencil. Hold on. Gosh, I'm not sure. I'm going to continue. Cosecant, right? If we think of this, inverse cosecant, if this is the function f of x equals cosecant x, right? It's going to have an inverse on negative pi over 2. Try to do my best to pick up the pen here. It's not working. Uh-oh. Ah! Major technical difficulties. Negative pi over 2 to 0 union 0 to pi over 2. Okay? And then we can also see cotangent, right? Which means inverse cotangent of x means x is cotangent of y, and cotangent of x, this is the graph of cotangent of x, it has an inverse on 0 to pi. Okay, so those are the restricted domains for which these other three trig functions have inverses. Alright, it looks like my pen here, my stylus is going to need some batteries soon, but it looks like I can get it to work for a second. Okay, we're going to find inverse secant of -2. Now remember what this means. This says secant inverse of -2 is the angle in our restricted domain, so that's from 0 to pi over 2, including 0, union with pi over 2 to pi, whose secant value is -2. Oops, not -12. -2. Okay? You might say, what? I don't know. Well, think about this. We know that secant is the same as 1 over cosine of x, right? And so if this whole thing is equal to -2, which we just said is true, flipping both sides over here, we know that cosine is -1/2. Okay? Alright, so now let's go to our unit circle. Think about the interval in which we have the inverse secant defined. It's from 0 to pi over 2, so here's 0 to pi over 2, all the way over to pi, right? So this is the interval where we have angles that we can do the inverse secant for. And turns out which one in this interval has cosecant -1/2? Well, that means x-coordinate -1/2. Right? That angle's this angle here that I'm drawing, which is 2 pi over 3. Okay? Alright, so that means that secant inverse of -2 is equal to 2 pi over 3. Alright, so the key of finding these is to take your cosecant, secant, or cotangent and changing it using the identities that we know into cosine, sine, and tangent, and going from there. Sorry about the choppiness of this video. There's people in my house making lots of noise and I keep having to pause it. Anyway, then the last thing that I want to show you is something that may seem a little bit confusing, but it's something that's really helpful when when you're in calculus. We're going to write an algebraic expression in the variable u for cosine of cosecant, inverse of u. Now you might say, well, this expression is already in u, but it's not algebraic, it's trigonometric. What's an algebraic expression? Well, it's an expression that involves the operations plus, minus, divide, multiply, square roots, and variables. So and or constants, right? So we don't consider these expressions to be algebraic at all. They are trigonometric. So we're going to write something in algebra. All right, well, what? Okay, this is what you do. You take the inner function, cosecant inverse of u, and set it equal to some angle, right? We know that cosecant inverse of u is the angle whose cosecant is u, right? So it is an angle. We'll call it theta, okay? Now, by the definition of inverse cosecant, we know that cosecant of theta equals u. These two things are the same, but we have to be careful where theta is in the interval -pi/2 to 0, union 0 to pi over 2, right? And on the unit circle, that's here, right? If you think of this as pi over 2, this is 0, and this is -pi/2, right? Okay. So we can plug in then, we can take our original expression to say cosine of cosecant inverse of u is the same thing as finding cosine of a theta, right? Where theta is here, right? It's one of these angles inside this interval. All right. Well, since theta is in this interval, then we know some things about it. We know that cosine theta is positive, because it's in quadrant 1 or 4. We know that secant is positive, since it's 1 over the cosine. We know that tangent of theta is negative, because it's sine over cosine. That's in both of these quadrants, quadrant 1 and quadrant 4, sine and cosine have the same sign, S-I-G-N sign. So that makes tangent negative, they have opposite signs, pardon me. So that makes tangent theta negative. Wait, hold on just a second. Wait, scratch that. In quadrant 1, tangent would be positive, and in quadrant 4 it would be negative, and similar with cotangent. And as far as sine or cosecant are concerned, the same thing. In quadrant 1, sine is positive and cosecant is positive, and in quadrant 4 they're both negative. Okay, so we can't really tell much about the other four trig values. So tangent theta, cotangent theta, so we'll say and sine theta, cosecant theta are positive or negative, right? All right, so why do we care about this? Well, to write this as an algebraic expression in u, right, we want the whole, we just said that u, right, is equal to cosecant theta, right? So we want to be able to write our original expression, right here, in terms of only cosecant theta, and then we can plug u in for it. Well, how do we get there? All right, and the ideas about the positivity and negativity of all those trig functions are really going to help us. All right, so we have cosine of cosecant inverse of u, right? We already said that's equal to cosine of theta. Watch what we're going to do. We're going to say, okay, cosine of theta times sine theta over sine theta is the same thing as cosine theta, right? Okay. And I'm going to rearrange that a little bit. I'm going to put cosine theta over sine theta and then have this sine theta out here on its own. All right. Why did I do that? Well, recall, right, that 1 over sine theta equals cosecant theta, right? And that also is the same thing as saying that cosecant theta is the same as, that's not what I wanted to write. I wanted to write sine theta is the same as 1 over cosecant theta, right? Now if I want to write this expression all in terms of cosecants, right? Well, sine theta then is going to be 1 over the cosecant of theta, okay? And let's see, I can't write cosine and sine in terms of cosecant, but cosine over sine is cotangent theta. And remember that cotangent squared theta plus 1 equals cosecant squared theta, right? And if I solve this for cotangent of theta, then I can say that that's the square root of cosecant squared theta minus 1. All right, so I'm going to replace then the cotangent part of this expression with the square root of cosecant squared theta minus 1, and we're going to multiply by 1 over cosecant theta. So what that means then is that the whole thing is the square root of cosecant squared theta minus 1 over cosecant of theta. Now remember that cosecant, so we called cosecant theta u, right? And I want you to think about this. We said earlier we don't know whether cosecant is positive or negative, right? We're not sure about the sign. So it's not enough to say that cosecant of theta is equal to u. We have to say it's equal to the absolute value of u. Okay? Why? Well, we already know that theta is in these two quadrants. And notice what we're really looking for after we plug in theta for cosine inverse of u is we're looking for cosine of theta. Well, cosine of theta in both of these two quadrants is positive. So I need to make sure that this expression, because it's equal to the cosine of theta, is all positive. Okay? That's why we need to do this here. All right. Now, if I do the square root, plugging in for cosecant, I put absolute value of u squared minus 1, and then I'll put in absolute value of u here for cosecant. Well, the absolute value of u squared is just u squared, right? Because that's always a positive value. So we get square root of u squared minus 1 all over the square root of u. And this can be really helpful for us in calculus because taking what we call integrals and derivatives, you'll find out what that means, of algebraic functions can sometimes be easier than trigonometric functions.